I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this series, we are preparing students for the highest level of competitions globally. I'm going to take some questions from past competitive exam papers. We'll discuss them at length, and I hope many of my subscribers will benefit. Some of you can also contact me for learning directly. The idea is to have creative thinking to solve such questions. You can contact me on the email address given here, and we can have Zoom classes one on one to prepare for the toughest competitions. Hi, Amy. How are you doing?
Hi, sir. Yes, I'm doing well, thank you. How are you?
Very good. So, today, what do you want to do?
I was hoping if we could just kind of continue with some, those like exam questions that were kind of varied on various topics of our course, just to, keep the mind going about how to approach different questions. That would be really helpful.
That's great. Last time I remember you had three questions from three different topics, altogether three
Yes.
different topics. So let's see what you have for today. You can share your screen, and then from there we can go. You can share your screen.
Yeah. Let's see. So we had this proof question.
Okay, so can you please read the question? We'll work on it.
Yeah. So let n be any positive integer that is not a square number. Prove by contradiction that the square root of n is irrational.
So we have to prove that square root of n is irrational. And we are given n is positive integer, right? So we can say n belongs to z plus, that is positive integers, correct?
Yeah.
So that's it. When we say prove by contradiction, it really means that we have to assume that when we want to prove that this is irrational, we'll assume that this is rational. If you get the idea.
Yeah.
The first step is assume it is rational.
Assume root n is rational.
Rational. So that will be our first step. And once we assume, then what we do here is that we logically prove that that is not the case. That is not the case means logically show that you reach somewhere which is impossible or incorrect or mathematically wrong. So that basically means it leads to something that is impossible.
So you contradict your assumption.
Incorrect, yeah. Or logically wrong. Something like this, right? Logically wrong. That is the whole idea, right? So we'll begin by assuming that square root of n is rational. So we do that assumption first. So we say let square root of n be rational. Is it okay?
Yeah.
Now rational means what? It means that square root of n should be equal to p over q, where q is not equal to 0, and they are in the lowest terms. That means no common factors.
Yeah.
That is what it really means, right? Now, let us square both sides. If I square both sides, I get n equals to p square over q square, right?
Yeah.
Correct? So I have n equals to p square over q square.
And now we know that n is an integer. It is not a fraction kind of a thing. You get the idea?
Right.
N
Yeah.
is an integer, right? Since n is an integer, any prime factor of q, because p and q are other numbers, right? So any prime factor of q should be a factor of p also, correct? Because that should be evenly divided. Do you see that? So that means any prime factor of
Prime
q
factor.
squared. Because see, q is a composite number, right? P is a composite number, correct? Let's say you're dividing 10 by 6, for example.
Yeah.
See, if you divide 10 by 6, 6 is like 2 times 3.
Yeah.
But 10 does not have 3 as its factor. In that case, 10 divided by 6 will not be an integer. Do you get the idea?
Because it doesn't have 3. Okay.
It doesn't have 3. You
But
see
it has 2. Yeah.
It has 2. So if you see, it is
Oh.
like 2 times 3, right? So if I
Yeah.
do this division, I get something which is not an integer. Do you see that?
Mm-hmm.
Because the numerator does not have 3, which is a prime factor of denominator, as its factor.
Oh, okay.
So that means
So
every prime factor of q square should be a factor of p square also. Then only you get n as an integer. You get the idea?
yeah.
So that means any prime factor of q square should be factor of p square, right? So that means any prime factor of q should be a factor of p. Do you get the idea? If you have a factor of p squared, right? For
So
example, in this particular case, kind of, if I do square, right? So 3 square, I need a factor of 3 square in the numerator, right?
Yeah.
So that means a factor of 3 also, right?
Yeah. Yeah.
So
it can be whatever, like cubed or to the power of 4. It just needs to have the 3 there because
it has to have
that's
the
what
3
it's to the
there.
power of. You're right.
Yes. So any prime factor of q square is a factor. That means they have a common factor, right?
Mm. Oh,
And
I
that,
see.
because they have a common factor, it actually contradicts our assumption.
So it's similar to what you did,
Yeah.
but it's just the fact that the one that we did like previously, you like
Yeah.
instead of writing it all in sentences, we mathematically showed there was a common factor of 2 and stuff
Yes.
like that. This
Yes.
is just more wordy. I see.
More
Okay.
wordy. Yeah. So it contradicts the assumption that square root of n is rational. Is that okay?
Yeah. Therefore, we've proved the original statement.
So from contradiction, we have shown that this is actually irrational. It cannot be. So therefore, square root of n is
irrational. Okay.
So we proved by contradiction. Do you understand?
Yeah, yeah. So 4 marks, 4 statements.
Correct. I mean, it is very important to understand these statements since you never know what type of question is there in your exam. So if you know multiple ways of proving, right, it is always good. Yeah. So you remember last time we did square root of n is irrational. Square root of 2 is irrational. Do you remember that?
Yeah, they're very similar. Same approach.
Irrational. So we had a slightly different approach. We just squared and then we say, well, 2 is a common factor, correct?
Yeah.
So it's like this. But this is like, as you rightly say, more wordy. So we're playing with words and trying to.
Yeah. But in this question, like, when we did this game question where we did it the different way, we how when we came across the part where it said, so let n be even or odd, does that not play in here?
You could do it, yes. Even you could do, right? So if n is even, then we can show that P or Q both are even, right?
But in this question, we didn't need to say whether n was odd
No,
or
no,
even
we don't.
because
We are generally
we got the
prove
prime factor.
any integer for that,
Oh,
as the
okay.
question states. So let n be any positive integer. So we are working on that specifically, and we are showing that that is the case. If it is any positive integer, so integer is the important thing, right? So if you write in P over Q, writing in P over Q means all factors of Q should be factors of P. Otherwise, you cannot simply divide it. You'll get some remainder.
Oh, that's true. Yeah, yeah.
So this is a good approach.
Wait, so is this the only approach then?
No, no.
We can't have the other way.
We can assume and let n be even, right?
But if you do that, does that mean you're neglecting the odd, or is that because it doesn't play on the statement of any
Whenever you
positive?
want to do by contradiction or prove, I mean, prove.
Oh, you just need one.
It should be true for each and every possibility, right?
Oh,
so if
right.
you get one contradiction, it's okay. It's
oh, okay, that's all right. Yeah, yeah. Okay, good.
So is that clear to you?
Yeah, very clear.
Great. So let's move on to the next question.
Okay. So let's see this one.
Okay. Can you please read this question? Pretty long now.
Yeah. All right. So a mass mkg of a substance decreases with time t years. The mass of the substance can be modeled by the equation m equals a b to the power of t, where a and b are constants. Part A, show that the graph of ln m against t is a straight line.
Okay. So that is simple. You take log both sides, correct? So when you take log both sides, you get ln m equals to ln of a b to the power of t. Is it okay? So we get ln m equals to, applying the properties, right? So you remember the product rule, right? We could write this as ln a plus ln b to the power of t. So this means ln m equals to ln a plus t times ln b. Is it okay?
Yep, the t comes down.
So this is equation of a straight line. We say what? The graph of ln m. So this is y. Do you see that? So let me write this as capital Y, right? And that is a constant, c, plus t is a variable, right? And ln b is the slope. So mt. Do you see that? Where m is equals to the slope ln b of this particular graph. ln b is a constant, right? So ln b is also a constant. So when you sketch this particular graph, what will you get? So let me just sketch it here.
Wait, because it's y equals mx plus c form, can you just say that's a straight line?
Correct. That's what I'm trying to say, right? Well, c is the constant, right? So this is c, right? And that is your y. This is your t, correct? The variable, correct? And the slope, rise over run, is m, which is ln b in this particular case, correct?
Yeah.
Slope is ln b. So that is how you could show that the natural log of m for any exponential equation, that is the way to do it, right? So we calculate the exponential equation using logs, right? You could do natural log or to the base 10 and get this. And this is also important from another chapter which you have is linearization.
Oh, right.
So that is a nonlinear graph we're talking about. M equals to a b to the power of t is an exponential function, which is nonlinear, right? But as soon as you take logarithms, it becomes a linear function. So when it becomes a linear function, interpretation is much easier.
Right.
So this is very helpful. So right, I'm just writing a comment here. Helpful for interpolation. Since you have a straight line, you can easily, work out what will the value be, correct? And even for approximation,
Yeah. Is this the same topic where you could like extrapolate or interpolate?
Yes. So you have a chapter which is linearization.
That chapter didn't ring a bell, but when you said interpolation, I was like, oh yeah.
Or functions, right? Do you understand?
Yeah, yeah.
So for exponential functions, this is the technique.
Right.
Okay. So what else? The graph of L and M against T passes through the point 0, 3.91. It takes 5 years for the mass of the substance to decrease by half. Show that A is approximately 50. So we can use this equation and then put the values here. It says, let's put these values. Let me use a different thing. Okay. The graph of L and M against T passes through the point 0, 3.91. So let's say we have a point here. Okay, 0, 3.91 is the y-intercept, C, right? So at 0, that means C is 0. C is equals to 3.91, correct?
Yeah.
It takes 5 years for the mass of the substance to decrease by half. So if I have another point here, which is like time 5 years, right? Then the mass becomes m by 2. Is that okay?
Yeah.
Fine. Show that A is approximately 50. So we know the value of C, correct?
So you said ln A equals 3.91.
Correct.
So A must
ln
equal
A. Yeah. C is ln
e
A,
to the
right?
power of.
Yeah. So we now know that ln A
e to the power of
is 3.91, right? So A is E. Can you calculate 3.91?
Yeah. So it says 49.898. So 50 approximately.
So that is how you're going to do this, right? Show that A is approximately 50. So we got the value of A, and we also know that C, right? So C is ln2, correct? So the intercept of ln M is known to us. Now it says, find to 3 significant figures the value of B. So because of the half-life, we can now find the value of B, correct?
Yeah.
So
is it T ln B, which is the mx?
Yeah, we can use the original equation. We don't have to use this equation now.
Oh, okay.
So half-life means M equals to A, B to the power of T. So that is your basic equation, correct?
We found A though as approximately 50. So.
Yeah. And now we know that half-life is 5 years, correct?
What's M though?
Pardon? M can be M. So basically, if M is what? Okay, that's a good point. So let's say if T equals to 0, let's write again this equation. M equals to A, B to the power of T, right? So if I write T equals to 0, that means initially, starting point, right?
M equals A.
So M equals to A. Do you see that? M equals to A. Which is A times, let me write T to the power of 0, and then I'll write A. It's absolutely clear, right?
Yeah.
So the value of A is 50. So we'll start with, do we need to write an approximate answer? Find to 3 significant figures. So I'll write 49.
Maybe 49 point, yeah. The one rounding issues.
Is that okay? Now, half-life means what? At T equals to 5, the mass is M divided by 2, right? Which is 49.898 divided by 2, correct?
Oh.
Simple as that. And it gets cancelled. So we don't really have to bother that much. A is 49.898, correct? They cancel. So it doesn't really matter much, right? So B to the power of 5. Is that okay?
Yeah.
That 49 thing cancels, correct? Whatever you write, 50 or 49. So now we have half here, B to the power of 5, correct? Take log. Again, you can take log ln, right? So ln of half is equals to 5 times ln of B, right? Or you can do 5th root. Wait, we can just do, so B is equals to 5th root of half. Is that clear to you?
Wait, so we're subbing all of this into the M equals AB to the power of T.
Yeah. And M is half of what it was. So M and M cancel. You get the idea.
Oh, yeah.
A is the initial mass.
Oh.
A is the initial mass, right? So A is m0, initial mass, correct?
Yeah, so b to the power of 5 equals half. So b equals the fifth root. Okay, yeah.
Fifth root of half, correct.
So let me quickly do that. Fifth root of 0.5. 0.871 to 3SF. I think that's what this is.
So, Amy, before we get into this particular question, can you note down all the values of A, B, which we calculated, and M? M is 8, right? And then we'll continue with the solution, okay? So let me clear the screen. Okay, great. So can you please again read this question?
Yeah. So after 8 years, the substance is modified to increase its mass by 20 kg. The mass of the substance then decreases according to the model.
Correct. So we want to find this mass here, right? How will you find it? Tell me.
So it says after 8 years, the substance is supposed to increase. So we need to find the mass at 8 years using...
So M equals to AB to the power of T, right?
Yeah, using that formula. And we've already got all the values, so we can just...
What are the values? M equals to, what is the value of A we got?
So 49.898.
49.898. 898. Okay, and B value was?
0.871 to the power of 8.
8. Yeah, calculate.
16.5286.
Right. So that becomes the mass after 8 years when it was decaying, right? So mass was decaying, it came to this level. Now it says this is after 8 years, right? After 8 years, the substance is modified to increase its mass by 20 kg. So after 8 years, we added 20 kg to this. You get the idea?
Yeah.
So it becomes what? 36.5286, correct?
Yeah.
The mass of the substance then decreases by this formula, right? So now we can find the value of P. So that becomes the initial mass, right?
What, 36.52?
Yeah, this is M, right?
Oh, okay.
Modified. So now we need to find what P is. At this time, we have started a new series and we'll take T equals to 0, correct?
Oh.
So we have 36.5286 equals to P plus 40 e to the power of minus. What is this? What is this?
0.32.
0.
What doesn't matter because it will end up being 1.
E being 0, right?
Yeah.
Correct. So from here we can find the value of P. So what is the value of P?
36.52 minus 40. Minus 3.471.
No, that. Oh, okay. So you did, okay, you brought it this side. So that is 1, correct?
Yeah.
So P equals to 36.5286 minus 40, correct? And you get that value as minus?
Minus 3.471.
Okay. So that's what you get. So P is a constant with this value.
Yeah.
Find the value of P. So that is how you're going to do this particular question. Is that clear to you?
Yeah, so the hard part I didn't really get was, so after we found the modified one, you have to start a new series. So make it T equals 0.
At this time, we added 20 kg. Do you see that plus 20? And then it starts decreasing. Then again, it starts decreasing. You see that part?
Oh, from there. I see. Yeah. I was trying to do it from the same one. So I was like, what's the time then? Because we don't know. It could be like anything. But because it's starting again.
Correct.
Yeah.
Starts again. So it's a very interesting question. I hope you get it. So this is what happens at 8 years, right? So that's how we are going to do it.
Mm-hmm.
Okay.
Let's check.
Yeah. You got some value, right? Very small. Yeah. I think it's same, right? 3.5. They write minus 353. So some calculation you have to check, I mean. You got 3.4.
36.52. Oh, they didn't use the round. Oh. See, you know the value of A, the value of B, where it was to the fifth root of a half.
Yeah.
We did 0.871. You can't, they didn't do that. They did 8705.
Yeah, they
I was
use
supposed to
4
use the
decimal
full
places. So
thing.
you have to be careful, right?
Oh,
So because the rounding is very, see, so that's why we got an
pretty
error
annoying.
here, very important. So this value, which we use 0.871, do not round to 3 significant figures. This is 3 significant figures, right?
Yeah.
So
really
use
annoying.
4
Okay.
decimal places, okay?
Yeah.
So note.
Fifth root.
Yeah, use, because if you want 3 significant correct figures, you have to use 4 decimal places.
That's true. Yeah. So 0.87055.
Yeah, and that
Anyway,
caused
the method was correct. So
yeah, so that caused the error here, 3.5 and 3.4, right? Do you understand?
yeah.
So that way is correct. Yeah. And they do write correct answer is what? What do they write? Correct answer 3.5 is acceptable, right?
Yeah.
So 3.47 is close, but oh, in that case, you could round this and
Yeah, I
write
could
this as
round.
minus 3.5. Okay.
Mm.
Anyway, so the method was correct. And important learning here is that use the values to 4 decimal place to get the accurate answer. Clear?
It's because of part A, B, and C, because you found the values, you think those are the values, but they're not.
Correct. Correct.
Yeah. So minus 40. Yeah, I got it.
Yeah.
It's
yeah. So they the square root of half, which they did, they used 4 decimal places. Do you see that? 0.8705, which was rounding to 871, and we used 871, and that's why we got this error. Is that okay?
Oh, I see. Yeah.
Perfect. Otherwise, it was good. Anyway, that's good. Good question. Can you please share the next question now?
Yeah, this one. I've actually learned this just recently in school.
Okay, so you learned this?
Yeah.
This is called wave equation. You know that?
I don't know what it's called. What is it called?
Wave equation.
Oh. I don't know what my book calls it. I think they just say something. They just say, oh, they say alternate method.
Oh, I see. Okay. So
in R form.
So what is the question? F of x equals to 12 cos x minus 4 sin x, right? X is between 0 to 2 pi. Express f of x as in the form of r cos x plus alpha, right? So any wave, any periodic wave can be actually modeled as a sinusoidal function. That's the whole idea. Any periodic. So we are rounding this. So how will you do it? Tell me now when you know it, right? So we have r cos x plus alpha. How will you do it?
Yeah, so just by using that form, we want to expand it knowing our previous cosine addition rule. So it'll be r cos x cos alpha minus, it's minus, right?
Yeah.
Okay. R sine x sine alpha.
Correct.
And then you've got the original equation. So just by comparing coefficients, you can see that r cos alpha equals 12 and r sine alpha equals 4.
Correct. So you can
then
square and add them, right?
Yeah, to find r. So 12 squared.
R square equals to 12 square plus 4 square. R is equal to square root of 144 plus 16, correct?
Square root of 160.
Square root of 160, correct?
4 root 10.
4 root 10. Perfect. So that is the value of R. Tan alpha is sin alpha over cos alpha, right? When you divide, you get tan alpha, correct?
A third.
And tan alpha is 4 over 12, which is 1 over 3, correct?
So alpha is, they want it in pi, so I need to check that I'm in radians.
Tan inverse 1 over 3, correct?
Yeah. So 0.3, they want it to 2 decimal place. So it's 0.32.
2 decimal place, 0.3. Perfect. So that is how you're going to do it. So very standard equation to remember. Very important question here. So R basically equals to whatever are these coefficients, let's say A and B, right? So it is A square plus B square squared. Is that okay?
Yeah.
So that's what we get. And alpha is basically equals to tan inverse of A over B. So coefficient of sine, which was 4 here, right? So I should write minus A over B, right? because this is minus of minus, because the formula has that minus thing, right? So tan inverse of minus a over. Is it okay?
Yeah.
So we have 4. Do you see that? It is minus of minus 4. So this becomes your standard formula to convert into r cosine x plus alpha. Now, when you have this equation, you can easily graph it. You get the idea. So now you have
the
an equation
vertical
4 square
stretch.
root 10. Yeah, cos of x minus 0.32, correct? Now you can easily graph this. It's a cosine function, correct? Earlier,
you can have a
it's
parent
combination
function
of sine and cosine. So it was very difficult to graph that particular function.
Oh.
So that's the whole idea of finding this equation. Yes.
That's really smart.
Yeah. So now you can graph the function f of x. Earlier, it was very difficult. How could you do it? Cos x and sin x.
Could you have squared it and then made sine squared x in terms of cos?
Very difficult. You could do many things, right? But this is so simple. Cosine function.
Oh, no, yeah, you can't square it because the cos and sine will be together.
0.32 to the right and amplitude is 4 square root 10. You're done. It's so simple.
Yeah.
Right? So,
well, whoever invented that is quite smart.
Yeah, it's very important equation from physics and mathematics point of view. Yes. Okay, so we're done part A. What is B? Solve f of 2x equals to 4. Yeah, just substitute in this now. So f of 2x will be what?
I have no idea.
So, okay, so f of, shall we remove this? Remember this, right? You give
me
the
I wrote it down.
I'm erasing, okay?
Yeah.
So what is f of x equals to?
So f of x is equal to 4 root 10 cos x plus 0.32.
Plus or minus? Alpha was positive.
Plus. Yeah, because it was 0.32.
Yeah. 0.3. Correct. So what is f of 2x? Replace x.
Well, you just put 2x where x is.
Correct.
Wait, so do we write 0.32 or do we have to use the not rounded version?
No. Oh, I see. That's the important thing.
I'm not doing the same mistake again. I don't know. I'm asking.
Yeah. That will make huge difference. So what was the value which you got?
Oh, would it? Oh, 0.3217.
Yeah, let's use 4 decimal places. No problem, right?
Okay. Just in case.
Yeah. Because we landed up with an error last time, right?
Yeah.
Okay. So we have 4 square root 10 cos 2x plus this equals to 4. Now you can divide. So you get cos of 2x plus 0.3217 equals to 1 over square root 10, correct? 4 and 4 cancel, correct?
Oh, yeah.
So you get 1 over square root 10. So now cosine is positive. We want to find the answer between 0 to 2 pi, right? So you have 2 solutions to this. And therefore, it's very important to find the related acute angle and then the other angle, right? So let's find alpha. So alpha is equal to cos inverse of
1 over root 10.
What do you get?
You get 1.249.
Okay, so that is alpha. So the other angle here will be 2 pi minus this, correct?
Yeah.
So the other angle is, let's say theta, let me write theta, right? So theta is equals to 2 pi minus 1.249. What do you get?
2 pi minus that. 5.0341. 5.0341.
Another important point here, I'll just share with you. It is cos 2x. So we have to
change the domain.
Change the domain from 0 to 2x. When I say it will be to 4 pi. Do you see that?
Would it have to be plus the 0.321?
Oh, yeah. But I think we'll check that. We'll check that part, right?
Oh, okay.
So let me rewrite this. We'll write this as cos of 2 times x plus divide by 2. What do you get?
We're doing the 0.3.
160, and then you may write 8.
0.1608.
Yeah.
Wow, sorry, you did that in your head. That's
Okay.
so hard.
So that is the one you're getting, right? So you notice that there are actually 4 solutions for this equation, right?
Mm.
So this basically means that you have this cosine function going something like this, and you're looking into 2 waves. So you expect a positive answer. So we have this, 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 and this. There are 4 answers. Is that correct? Correct?
Yeah, but why are we only getting 1.24 and 5.03?
No, we will calculate. So we got 1 and then 2 pi and then keep on adding 2 pi to both. You get the idea.
Oh, yeah.
So this
But
is
then
like
we can't go past the domain that
1, 2,
4,
yeah,
5.
yeah. Theta 3, theta 4, right? Fine. Add 2 pi to first. So 1.249 plus 2 pi.
Yeah, I got 7.532.
And 5.03
Won't that go over the domain though?
plus 2 pi.
Oh no, it won't.
It won't. We will calculate. We'll see. Don't worry. How much do you get?
5.03413
Plus 2 pi. 611.
plus 2 pi. It's 11.317.
Correct. Calculate this. What is 4 pi equals to in decimals?
12.5. Oh, that makes sense. Yeah, 12.5.
You see that?
Yeah,
it is within.
right.
Right? So we got all those 4 values. However, the true answer will be 2x plus all this, or you can write this, right? You can say 2 times x plus 0.1608 is equal to this value of 1.249. Is it okay? So
x for each solution, we have to do
divide. Yeah, one I am showing you in details, right? You can divide. So you get 0.6249, correct? And so x will be equals to 0.6249 minus 0.1608 to get your first answer. Is it okay?
Yeah.
You could do like this. And similarly, you find with the others, correct? So this is x1, then you get x2, correct? You could do that. Now, you can also do one thing, that the period of this function is pi, because there are 2 ways, right?
Right.
So that is one answer. The second answer will be how much? Add pi to this. Do you see that?
Oh, yeah, you don't have to sit there and
you don't have to do these calculations again for these 2. You get my point?
Oh, wait, why is it add pi though?
Because the cycle now has a period of pi. So it repeats after every pi. So then next will be like, do you see this for cos 2x?
Yeah.
So you can verify. Similarly, when you do the second one, add pi to get your 4th answer. You get my idea?
Yeah, yeah.
So you save time by doing...
Instead of dividing, subtracting.
Yes.
All right.
Yes. You save time. Even from the first calculation, you can get all of them. You get the idea? You can get all of them because I know that the whole thing repeats after pi, not 2 pi. Correct?
And you know that because of what?
Because it is cos 2x. Because of cos k value is 2. K value k. Yeah. Okay. Since k value is 2, right? Cos 2x. That means time period is 2 pi by 2. This is pi.
Yeah, pi. Oh, yeah.
So the full cycle repeats not after 2 pi. It repeats after pi, right?
Pi.
So I'll suggest, safe side, calculate from first 2 values, and for the other repeated values, keep on adding pi till you are within the domain. Till you are within the domain of 12.5. You get the idea?
Yeah.
So you get all your answers.
Oh.
Does make sense to you?
Yeah.
Right.
That's very clear.
Yeah. And the initial, So initial value will be okay. And the value should be more than 0.3. So first one is not valid. You see that first one is not valid. Oh, it is valid. This is the value. 6. Yeah, it is valid. It is valid. It is valid. because it is 0.6. Okay.
So aren't we subtracting the 0.16 from it?
Okay, let me clear the screen. Do it once again to show you the domain. Okay?
No. Oh, yeah.
Okay, you want to see the values? Okay. Copy.
Oh no, it was just that you see where you highlighted 0.6249. Below it, we had to subtract 0.1608.
Yeah. Only thing I have to do is like this, right? So
yeah, so the value was 0.46.
Yeah. So I have to subtract. So minus 0 point. So I want to redo it on a fresh page. Okay.
Mm-hmm. Do you want me to zoom out?
So basically, it was cos of. Okay, that'll be even better. Okay. So we are working on cos of. Can you tell me? Equation was x plus how much?
I didn't get the part. Wait, divided by 2. 0.16.
4 square root 10. I'm forgetting, but okay.
Yeah. 4 root 10.
Okay, let's rewrite.
4 root 10 cos x plus 0.1608.
So we factored out 2, correct?
Yeah.
So we know k equals to 2. That means time period is now 2 pi by 2. So the time period is only pi. Is that clear to you, first part?
Yeah. Mm-hmm.
Second part, which is very important to consider, is the domain, right? So x is between 0 to 2 pi, both included. So now we can do multiply. We could actually take away. We can add 0.16, correct? We could add this. We can do either way. So we can add 0.1608, right? X plus 0.1608.
Yeah.
5 plus 0.1608. And then we'll multiply by 2, right? So we get what 37, whatever it was, correct? Oh, 1608. Multiply by 2. So without factoring whichever you got, right? You get the same thing.
Yeah.
So 4 pi plus 2 times this, 0.332 something, right? Correct?
Mm-hmm.
So I'm just writing 0.3. So your theta value, which we are trying to figure out, is basically between 0.32 to 4 pi plus 0.32. Do you understand now? Since it's shifted by point, that's some value.
Oh, yeah.
You get the idea.
Yeah.
So
it's really important to change the domain.
That is how you'll do it, right? Okay. So anyway, we got our answers. Using your answer in part A, find the minimum value for the function and the values of at which the maximum occurs, correct?
Find the maximum value, yeah.
So you can find minimum maximum values. As far as cosine function is concerned, cos starts with maximum, correct?
Cos starts with, max at 0, 1.
Yeah. So, and it shifted to left by 0.16, right?
Oh, you're doing it that way.
It shifted left to 0.6.
If you didn't take like...
Pardon?
If you didn't take like the 2 out, oh no, you should take the 2 out, otherwise it's really confusing.
Otherwise phase shift will be wrong. That's why that question is there. Is it okay?
Oh, so is that where people get it wrong?
Yeah, so the maximum will be at minus 0.1608. And the y value will be 4 square root 10. You get the idea? The minimum will be add pi to this.
Wait, the 2 inside is the horizontal stretch.
Compression. Therefore, the time period is pi, correct?
Yeah.
So the time period is pi. So the whole cycle goes pi, and this is like pi by 2. You get the idea. So it says what? Using your answer, find the maximum value of the function f and the values at which the maximum occurs. So maximum occurs at add pi to this, right? So maximum value is 4 square root 2, 4 square root 10. Which is the amplitude? Is that clear?
But the x value is minus
Yeah,
0.
x value is and plus pi. Keep on adding pi to this, right? Because this is time period is pi.
How do we know when to stop? When it's in the time period.
When it is within 2 pi.
Oh, wait, it's still in that domain. Okay, the domain, yeah. Right.
Yes, yes. We already took away minus 1.6, so it will remain in that domain. Do you get the idea?
Oh, yeah, yeah. So we're adding, do they want, when they mean max value, do they want y value or x value?
Yeah. So first thing is maximum value, which will remain constant, which is 4 square root 10.
Yeah.
At which, and the values of x, I think that's
okay.
At which this occurs.
It's really weirdly worded, right?
Correct.
So minus 0.16 add pi, so you get 2.98. Yeah. That's one of the values.
And then the other value, correct?
2.98, then I add pi again, you get 6.12, but that's not in the domain.
So only these two are in domain. So you have to report these two values.
Oh.
Because your domain
because 2 pi is 6.28.
Is between 2 pi to 0. Is that okay?
Mm-hmm.
So you have to report only these two values. So add pi and again pi.
Yeah.
To get the value, two values. Is that okay?
Mm-hmm.
So you get those two values.
So if it wasn't a nice number like 2 that we could take out, you still have to take out what happened if you took it out and then it became like a third x plus?
That's okay. That's okay.
Oh, okay.
Yeah. Whatever is there, you have to factor it out, right? And that factor is k value, which is going to give you the time period.
Time period, right. Okay.
Perfect.
Yeah.
So we'll clear this and move on to the next question.
Okay.
Oh, just 2 minutes left, I mean. So we can take those questions later.
Yeah. That's all right.
Yeah. So can you summarize today's learnings?
I can. So we touched upon the proof again, just a different kind of approach to it. It's again, obviously the same steps in terms of contradicting, making that assumption and proving that our assumption is incorrect. But it was more wordy and kind of talking about the prime factor of q squared also being the same as p squared, because we want the numerator and denominator to have the same prime factor so we can cancel it if it was rational. So that's what that was kind of going about. Then we had that exponential question. It's in terms of like learn natural log, trying to get it to correlate with y equals mx plus c in terms of graphing. So yeah, that question. The main thing we learned from that one was so if they have like a question and they're saying they wanted it rounded to like 0.871, don't use that value later on, even though that was the value given for that. You have to use the full thing, otherwise you can get rounding error.
So when you round in 3 decimal places, use 4 decimal places for your calculations.
Always one more than what the answer is supposed to be. Yeah. And then the final question was in terms of like you said, the wave
the wave function.
Wave function, yeah. So using the rules of that one and then solving. But yeah, a lot of graphing.
If you have a spring, correct, and if you just pull it and it oscillates, we can give you this wave function, right?
Oh yeah.
So many other wave functions, any heartbeat or any other periodic function, whichever you have, depending on from where it starts, that gives you the phase shift. And it could be written as a sine or a cosine function, r cos x plus alpha or r sine x plus alpha. It's one of the same. So that's called the wave function, which is you can graph and interpret many things from there. And even in that logarithm example, you saw how we linearized the curve, exponential curve, and extrapolated the value. You see that?
Oh yeah. So many topics are really linking in. Yeah, it's really good.
So great. We'll end the class here.
Yeah.
And I hope you learned a lot.
Thank you so much, sir.
Thanks.
I did. I learned so much.
Have a great
Thank you, sir. And you. Have a good one. Bye, sir.
Bye.